So here, what we are observing is cylindrical coordinate system. Let me write it again here. So cylindrical coordinate system. See, as it is, I tried already to make an element here. See, this is an element which I tried to make, but how to make it? No? Suppose say you want to draw it again, and this is no, this is one element which is shown here. This is a small portion of the entire cylinder which is shown here. So this is the small element, and this is a small portion which may lie here of the entire cylinder. So how to derive these things? That means, first of all, let me actually uh, show you. Okay, so the entire cylinder, that means the bigger picture. So let me actually draw that cylinder for you first, so that yeah. So let me make. Sorry, this is not straight. So this is y-axis. This is x-axis, and this is z-axis. Z, y, and x. So initially, what we try to do is that we make a shell, top cylinder top. Okay, we'll actually draw like this. It's not drawn. Okay, so symmetry. This is one. Right. So from this, let me take one portion here like this. This is something like this. See, I am trying to come up with a cylindrical portion, right? Cylindrical coordinate system. So this I project here down, and this one we should actually come down like this onto the y-axis projection, and from this place to this place as parallel to the top portion. That means we actually draw like this. So this is our cylindrical cylinder drawn on three-dimensional system x, y, and z axis. So this is the you know our notion or idea. Now next what? See, next what is that we want to see is that, suppose say now I come to this place, and then I draw a line like this. See, this is the as it is. If you see the cylinder, this is like a radius. Okay, let me again draw with a little more taper here. So this is this. Now this portion is the angle. This is theta bar. That is what we are trying to see. And this is the R. Okay. Now, if I move a differential element, small angle towards y-axis, that means like this. This small portion is nothing but d theta bar. So this small portion is, what is the small portion? D theta bar. So you should be, I think by now you might have understood how I got this particular lines now. Now what I do from these two lines, now this is arc. Now you can actually check this. Now this is an arc. Okay, this is actually entire the bottom for a cylinder. Generally, you take a cylinder. You have a cylinder like this. Sorry, yeah. So there is a cylinder like this. There is a cylinder like this, and then like this. So this is a circle, and this is a circle. The bottom portion we are actually here. We are actually here. So this is entire. I think this is the radius. Okay. So this portion, this is circle. In the circle, now if I take this, I know this angle, I know this angle. Now this becomes a sector. O, A, B becomes a sector. So this is the arc length. That means this is what? Arc length. That means if I know this as radius, if I know this angle as d theta bar, the length of arc AB would be r bar into d theta bar. That means to travel from A to B, what is my dimension is nothing but r into d theta bar. So this is actually from the what do you say, the sector point of view. See, I'm sorry, but the circle which I have drawn is not to the symmetry. Let me actually try. So this is a circle. This is a circle. See, generally, to draw a circle, you require a pencil, you require a compass. But as an engineer, you should take those things into picture and then draw it because you are representing on, you are showing it to somebody, right? So even I should actually do the same thing. Even I am not an excuse. I will try my best. Okay, so you have to draw. See, this is what I learned now. I have to draw in parts. So ultimately, this OAB, or I should say AOB, becomes a sector of a circle. So generally, I write it as angle AOB, and OA is equal to radius, OB is equal to radius, and angle AOB gives us d theta bar. Okay, now as of now, I am taking d theta bar. So what is the length? If I say lengthwise, length of the arc, it is given by this particular formula, radius into angle. Okay, next what? Now I project these two from this place to the upper portion. Yeah. So from this place, I go up, I go up, I go up, I go up, I go up. I'm here. From this place, I go up, I go up, I go up, I go up. Please use a scale when you draw. See, for this, this is the place. And this is a search center. So from this place again, I draw like this. And I draw like this. Okay. Now, our small portion of the element. See, already I have shown you. Okay. Our small portion of the element. How does it emerge? See, our small portion of the element, it should looks like something like this. Hope it is easy for you to understand. And here also there is a small portion, and so this is the element. So what I am trying to show you is a small portion. Now let me draw this here. Okay. Let us take the color of suppose say green. So this particular portion I take, and then a small portion here, and then I come down like this, and then like this, and then like this, and then like this. And this also goes like this, and this one comes here. So this portion, the total portion here is my element. This is the element. Okay. So this is the element. Now in this place, now you should actually understand better. So if I extend this place, that means if I extend this and go into this corner, yeah, let me take red color, and if I this point I extend and go to this corner. This is nothing but R, and this portion is dr. This small portion should be dr. The small angle is d theta. You know, we have dr, that means dr bar. So what we are saying this as, in our notation scheme, we are saying r bar, theta bar, and z. Cylindrical coordinates are given by r bar theta bar. Now this is dr bar and then d theta, but this length is also important for us. This length is important. So this length, what is this length? Okay. This length is what we are showing, and this length is what we are showing. So as you know, this element what we take is very small. There should not be much problem for us. So this is nothing but arc length, and this is dr. Okay, this is dr like that, and this is dz. The vertical line is dz. So here, if I try to make one coordinate system, let me take a purple one. So this is one, and then this is second, and then this is two. So this is axis what we are seeing here. Okay. Now the problem, or rather, how do we define our need here is that if I am here, this place, that means if I am here, if I am here, I want to travel to this place, that means this place. So three dimensions in the three axes, that means I travel dr and this arc length, and then I go up. This gives me the differential length. This gives me the differential length. What I'm trying to say, if I want to travel and reach, suppose say this length here, this point, if I take this as red color, so this point and this point, okay. From this is one, and I can go up like this, I can come up like this. So this makes one entire length to travel from A to D. So this A, B, C, D, suppose say like this. So differential length, so my answer, differential length in cylindrical coordinate should be dr plus BC. Dr, and I simply cannot write dr, right? Dr in delta r bar vector plus, next one comes what? R theta z. So now I should take theta next one. Okay, we'll take BC. So this is AB portion. Now BC portion, then CD portion. So BC portion should be dz delta z vector plus the CD portion is, it is CD. What is CD? It is not simply d theta. You should remember this r bar d theta bar was, this is arc length into Kronecker delta, or the direction what we are trying to say. So this is delta. So these, these are the lengths in the directions delta r bar, delta z bar, delta theta bar. So these are the three directions and these are the different lengths. So we have the ultimate formula for differential length in cylindrical coordinates. We'll see in the next session the differential surface in the cylindrical coordinates. Hope this session is little longer, but it is very essential to understand, because many times we take a small element where we say that it is a straight line, but this is arc length, so you should be very careful.